It's getting recorded, right?
Yeah.
Okay, yeah, I can start. Your first question is like battleships in a board. We are given a 2D board, and we need to count the number of battleships in it. The battleships are represented with X, and empty slots are represented with a dot. We may assume the following rules would be valid in that case. You'll receive a valid board which will be made up of only battleships or empty slots, and battleships can be placed horizontally or vertically. In other words, they can only be made up of shape 1 cross n or n cross 1, where n can be of any size. And secondly, at least one horizontal or vertical cell separates between two battleships. There are no adjacent battleships. Okay, so you know what is yeah. So if we look at this, according to the rules, the none of the battleships should be adjacent to each other, neither in the row nor in the column. It should be separated by a dot. That's why we have in this we have above two battleships. This in the first row you can see these two are separated, but here they are not separated. That's why we have only two of them. But here again they are adjacent. If you go row wise, they are adjacent. If you go column wise, they are again adjacent. So this is an invalid board for them.
So you
And
can
we
have
need
a single X also as a battleship,
valid
right?
shape. Yeah.
Okay.
Yeah, we can have. But if we have two, it should be uh, separated. I mean, a dot should be present between them.
Yeah, but you can have just like in the first example, the column which has 3x, the last
Yeah.
column. So it can have one x on the top and one x on the
One X at
bottom,
bottom.
right? Yeah.
Bottom, yeah.
So
Mid
that
shouldn't.
ships. Yeah.
Yeah. That because of mid, it's getting corrupted. Otherwise, it would have been 1, 2, and 3. If mid
Okay.
is not there. Yeah.
Okay.
And here, this also can't be there. They are consecutive. I mean, adjacent. And column wise also, they are not separated. So that's an
So
invalid.
what is the invalid in this case? Is it the mid row is an invalid
In this
addition?
mid row is in second one, right? You're talking about second example.
Right, the invalid example. Yeah.
Yeah, mid one is invalid because they are adjacent. None of them are separated by dots. I mean, dot should have been there if this second X was not there,
I
and
cannot
last X
hear
was not.
anything.
Oh, is it? I think can you? But I can hear you. Am I audible now, loud and clear?
Yes, you are. Yeah. You're fine.
Okay, I think she has to check the. Okay.
No, in this the middle row, so we have first three. If we would have had only first two x and the third would have been a dot, then it would have been a valid one, right?
Yes.
No, but again, two are adjacent. First two are adjacent. No. You are telling third should be dot if.
Yeah, if the third was a dot in the middle row, then it would be a valid one, right?
Yeah, it can be valid one, and there's two shapes, right?
No, but
One
they are
vertically and one horizontally.
Yeah.
1 and 2 are adjacent.
So that can be a horizontal shape. That is what I could think of.
At least one horizontal.
Yeah,
at least
counted as one.
Oh, if they are adjacent, they'll be counted as one.
Yeah.
Yeah.
Yeah, I believe in the second example, if the mid of the last column is not there, then there will be two.
Yeah, that third,
right.
Third one.
Yeah, mid of the last column also. Yeah, that also makes sense. Yeah, that can also be. That could be 3, right?
Three. Yeah. That will be
oh,
3.
sorry, 3. Yes, you are right. 3.
Yeah.
And there will be 3.
Yeah. So yeah, the problem statement is slightly confusing, but if you go through it many times, then I think it will be clear. Yeah.
We're not going to get any invalid input.
Sorry?
We're not going to get any invalid input, so we don't have to worry about that.
Yeah, that is what it says. But actually, to implement this solution, you have to understand this invalid case.
Yes.
You have to understand. I mean, how the input will come, how you have to count.
Right. Yeah, sorry, Shashank, go ahead.
Yeah. So it's like, and follow up is like if you can do it in one pass using using no memory and without modifying the value of the board. Yeah.
So
That
it means we
is
can
clear.
do without with extra memory. Like if we do a DFS, that is still possible, right? So only that we will be adding more memory, or even if you use a unified something like that, but
Yeah.
that will be an extra memory, but still the time complexity will be fine. So we
But
will
that
be
will
able
use
to solve.
implicit stack, right? DFS will use implicit stack.
Yeah, but the time complexity is still okay. Only the memory will be a problem.
Concern, yeah.
And that is what my thoughts are. But yeah, I think there is one example somewhere in this discussions about someone using a DFS. I never
Yeah.
tried that though, so it might be possible to use DFS. But I didn't see anywhere union find.
If you do DFS, how would you detect when there's a ship? Yeah.
So it's like, going to find, if we go through a DFS and keep on finding islands, okay, because we are sure that we are not going to get an invalid example,
Yeah.
right? So there is not going to be any invalid state. Just find islands. So all the islands are going to be ships.
So basically, the number of connected components.
Correct. Yeah.
So union find should work here, I think.
Yeah.
Yeah, it should. Yeah, but no one has used it surprisingly. So I thought it might be tricky to implement, but yeah. But they are
So
saying
it's
that
counting the number of island, right? That is the question then.
it boils down to that, right?
Yeah.
But the second example, invalid example, is also one island, but it is the invalid, right?
Yeah. And the problem statement says that you are not going to have any invalid examples in the test case. Yeah.
Yeah. Anybody wants to share code, something like?
But the O of 1 is tricky to implement.
So do we really need to do the DFS here? I mean, when we start from top corner and we move forward, so we can go only left and down, right? So right and down. And when we have to check that whether it says connected or not, we have to just check the previous one. If previous cell is not empty, either in the same row or same column, so that means we already counted that.
Yes.
Yeah. That is actually the easy way of implementing, but that's not very intuitive sometimes. So yes, yeah. But when you actually implement that, yeah.
Intuitively, DFS would work.
Yeah, because we are now programmed only for DFS and DFS, so maybe that comes always first.
Yeah.
That's why I think, they know that, intuitively, the candidate will go with DFS and they will use extra memory for that.
Yeah.
It's a follow-up.
So 1 by n and n by 1, what does that mean? In the question, it says that it has to be 1 by n and n by 1. Battleship can be only placed, in other words, they can only be made of the shape 1 by n.
You can have either single row, like all the ships in one row,
Yeah,
or
so
column.
all the connected will count as one.
Yeah.
Or either a single row or a single column. But in a row also, you can have some segments also. But as long as they are in a row, they are fine. So they will be counted as different ships.
Yeah, n can be anything.
Yeah.
People counting, it won't be like that.
Yeah, counting we'll have to. If we have segments in a row, then we'll have to count those segments as separate ships.
Yeah.
These 4 will be counted as one, because they are in one complete 20 second. Yeah. So if we don't have on the top and the down, then the answer would have been 1.
Yes.
Yeah. So yeah. So anyone wants to share the code, or it's like just iterate. It's not that efficient, like iterating throughout the entire matrix, and the moment you say you just continue, but you need to check If you have already, this is just for checking if you have already visited a X, you shouldn't visit it next time. In that case, you are not, I mean, like if you have something like repeated ones, X, 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 you earlier you had X, next time you are again getting X, then it won't be considered as a new island. So that is what I'm checking here. I greater than 0, I mean, previous row, this is for the previous row, and this is for the previous column. If you find there is a dot, that means we'll consider it as a new island and return the count.
Okay, so in your implementation, you are incrementing the count value only if you find a single X,
Dot.
but you are actually looking for a dot, right?
Dot, yeah. Or the other way around also we can do. We check if it is X and your adjacent one is not of, you have to do not of this is X, and not of again board I j minus 1 if that is X. In that case only you can increase the count. I mean, complement of this I'm saying. Rather than looking for the dot, you can go for X, which is like this I'm saying. You iterate through the entire this board. If you find first one as X and its adjacent is not X, row, either on the row side or the column side, then in that case also you can increase your answer.
Okay, so if you traverse the board row wise first, each row column wise.
Yeah.
So when you find an X in one location,
yeah,
you increment the count, and when you go to the next one, and if you still find an X, you just ignore that, right?
yeah, previous, I mean previous and up, you have to check left and just top of it.
Yeah, so first you will go from left to right, right, for each and every row.
Every
So
row.
once you find an X, you will just go increment the count, go to the next column in the same row, and if you still find an X, you will think it is a continuing, so therefore you are not going to increment the count.
Yeah.
Right, exactly. You do that for first row, and then you go for the second row, and the same thing happens for the column above that, the column above that. So then you actually ignore that X, correct?
Yeah, same like.
Yeah, so Python has like about 4 or 5 lines of implementation.
Yeah.
Yeah.
Where do you check if that's if it is the first row? You don't check if I equal 0. I see you check in the previous one.
No, this is, but this is not of, this is, I'm not checking for dot. I'm checking here for X only, whether you are having X in the previous row or not. I'm not checking for I equal to 0. That is the case I'll do when I have, I find first, when I find the dot, this one you are telling, right?
No, he talking the same thing.
Yeah, but in the second one, if you don't check for the first row, where do you check it from here, in here?
Actually, he looks for that board I minus 1, because when he's looking for IJ, so he looks in the second, if in the condition after and not, he looks for the board's previous row, right? I minus 1. And in that case, if he finds X,
we won't increment in that case.
Right.
Okay.
And same thing it does for the column also, J minus 1.
But then, are you starting I with 0? I mean, won't it go out of bound?
It will start.
But
it
board
will
of I minus 1 will be out of bound, right?
No, but I greater than 0, it's checking no here. Okay. Both the condition has to satisfy.
Yeah.
It will work.
Yeah, but she say you can start from I equal 1, right?
Yeah,
don't need to start from I equal 0.
But then in that case, then how is going to count if there is an X at 0, I0 and J0? So if you have X at the top left corner, so you won't be able to count that X, right? So therefore he has to start from 0.
I think 0, 0 will be taken care by this first one. Like initially will be I will be 0, J will be 0, right? So
yeah.
First X it will encounter, yeah.
Yeah, I don't. Okay, so let's say right now, I equals 0, 0.
Yeah.
Right. and then we have X there, and now I is equal 0. So this one become 4. Yeah, so they become true. Huh? Okay.
Yeah, why don't you run through an example, a test case?
Yeah, sure.
Quickly, so that will be slightly clear.
This one. So it will start first. It will check your at this board of wait. Let me expand it. This is your X, okay, and next it's checking for this one whether it's a dot or it's checking whether it is X or not. But
which one? The row 0 and column 0, right?
Yeah, row 0 and column.
I0 and G0.
I0 and J0. Yeah, the first one is checking for this.
Okay.
Yeah, and your next condition is I greater than 0, so it won't be satisfied. I mean, because in here your I is 0, so this will be false, and not of false will be true.
Right.
And this will also be your J is not greater than 0. See, this will also be not of false. So it's taking care that dot is here, so it will increase the count by 1. Next time you will go for 0 0, you done. Now 0 1 it will go. So 0th row and first column. Yeah, it will look for this. So here you're again, this will be false only because I is not greater than 0, and this will also be false, and both of them will be true. So it will increase the count by 1.
No, for the 0th row and first column it is dot, so board ij is equal to X. It is looking for that, so it's not going to go inside that. It's not going to increment the count, right?
This
the first condition itself is going to fail.
Yeah, I didn't look for that. Yeah, it will fail here. It won't count.
Right, so it's not going to count. Yeah, the second also the same.
Same. And again, you can go once you reach here, first one. Again, it won't count for this one.
But you'll go for the last column in the first row, right? Yeah, there it will count 1.
Yeah, this will count 1. But so first row you had 2 till now.
Right.
Yeah. Now when you go this again, it won't enter the loop itself. It won't enter for this. But when you encounter this, so when you will encounter this, your I is greater than 0 and its previous is not X. I mean, this is not X, but your top is again X. So it won't be counted. No.
Yeah, I minus 1 is X, right? So the second condition, it is going to be true.
This dot, right? I minus 1j will equal to X. So you are at this position at last.
Okay.
So its back is dot. Previous row, I minus 1 means previous row we are checking. So it will go to the top. Yeah, sorry, it will go to here. It will go to here. So this will be true and I is greater than 0. So not of true. This will be false. Again, it will not enter the loop. And same thing, it will go. So it will not enter. Then it will not be counted as one of the island. This X. Yeah. But again, when you go for this will be taken into consideration because of it will also not be counted, this third one. Right. Because when you check its top is your X, and so this entire condition will be false, and if one of them is false, again it will not enter. So from here 2 will be there.
Yeah. Yeah.
So it's like you go to a cell, check its top and check its left. If even if you have on top X, then that island won't be considered. Or either on left also, if you have that, won't be considered. Else, in other cases, you can consider it as a valid island.
Yeah.
Yeah, any queries on this?
Yeah, it's good. It's good.
Okay. Yeah, we can proceed then to next. So this is like we need to group the people given the group size they belong to. There are n people whose IDs range from 0 to n minus 1, and each of the persons belong to exactly one group. Given the array group sizes of length n, telling the group size each person belongs to, we need to return the groups there are and the people's IDs each group includes. We can return any solution in any order, and same applies for the IDs. It is guaranteed that there exists at least one solution. So it's like your ID is the people. So 0th belongs to group 3, 1 belongs to 3, 2 belongs to 3, 3 belongs to 3, 4 belongs to 3, and 5 belongs to your group 1, and 6 belongs to 3. So you can see that indices 2, 1, 6, 0, 4, 3, all this belongs to group of 3. They have group of 3, and this 5 belongs to group of 1. Or you have other possibilities, this, I mean, arrangement of this only, 0, 4, 3, 2, 1, 6. It's that arrangement only. Like you can say 4, 3, 6, it could be there, or the other way. I mean, you can have various possible arrangement of 3, 3 for this. Like you can take 2, 1, 0, one arrangement can be there. Like here they have taken 0, 6 and 0 from here, 6, 2 from here. So one arrangement is this, and remaining are 4, 3, 1. So they have grouped in this. But you can't plug 5 into this because it belongs to, fifth index belongs to group 1. So they have group of size 1. So you can have multiple answers. And if you look here, 0 belongs to 2. So there it lies in the group of size 2, and 1 belongs to group 1. So 1 will be here. Again, your 5 belongs to group of 2. So it falls in this category. And regarding 2, 0, 1, 2, they belong to size 3. So in this group, they are falling. And here, but you can't have other than here because you can't break this group into size of 1, 1 because they belong to group of size 2 only. And constraints are like group sizes is of length n, and n is less than 500, and all the elements are less than equal to n. Yeah, any queries here?
So this group size array, actually whatever the numbers are in that, so we can actually form a bucket, right, for each and every
IDs
value, whatever is in that group size array, and that put all those in all those valued indexes in a bucket, and then return that answer, and that is what it looks like, right?
You don't need the indexes, right?
No, these are indexes only, no, 0, 1, 2.
Oh yeah. Got it.
So the output is an index,
So
but
initially, if you go ahead.
So while collecting, we need to collect the buckets based on the values in the group size array.
Yeah, and if it is your, like let's say if you got a group of size 3 has 6 elements, you can break it into size of 3, 3. Like 3, a size of group 3 has 6 elements, right? 0, 1, 2, 3, 4, 6. But we don't have any group of size 6, so we will break it into size of 2, 3, 3 each. Otherwise, had there been a group of size 6, then 0, 1, 2, 3, 4, 6 will be in one bucket.
And you can return in any order. Okay.
Any permutation of this, or 0, 2, 3, or 1, 4, 6. Yeah, that's where the many possible answers are there. Yeah, any other approach, I mean, or anything somebody wants to share?
Basically, create a bucket if it doesn't exist and add that element. And if it is the size of the bucket is already equal to the group ID, add it to the result list and clear that bucket so that we can add it next time, right?
Yeah, that's another way to do it.
Pardon?
Yeah, that is another way to do it.
Okay.
So when you are saying buckets, you're trying to put in some map or something like that, right?
Yeah. I mean, first you select all the indices which are belonging into your that particular group. Like you have only 2 groups here, 3 and 1, right?
So instead of collecting all in one group, we add only that many. What is the group size? And if it is equal, then after adding the list, we can clear that and add again instead of adding to a bucket, right?
Yeah, that's also like you will have 3. first you added 3. The moment you reach 4, then you will remove all these elements and put again 3.
Yeah, after adding it to the result list, we can clear that and yeah.
Yeah, makes sense. But you have to store it somewhere, right? If you clear it in the same
result set, whatever we have to return.
Yeah.
It will create this, right?
Yeah. Mm-hmm.
And the good thing is you can return the output in any order.
Any order, yeah.
Yeah, so that is also an efficient way of doing it.
But mostly order will be this only because we are starting from left to right. So 0, 1, 2 falls here. If somebody will start from backside, then some other order will be there.
I think backside will be fine too, because we, as long as it belongs to the proper group.
Yeah. Makes sense. Anything should be fine, right?
I think we can have more combinations. It's only 2 they have mentioned.
Yeah.
That looks like, I mean, straightforward problem. Looks like it should be under easy category.
Yeah.
No, when you understand it is easy.
This IT people initially gets confused how this number came.
Yeah, the 3 things. The first example is confusing.
Yeah.
If you look at the second example, then it makes things more clear.
Little bit, yeah. So
yeah.
This
without the example, it would be hard to
understand.
Yeah.
But that's what it is in the interview, right? They only give us the statement and we have to come up with the example.
Correct. And also the statement is very ambiguous. So we need to talk to them and find out.
So they won't give example. I mean, yeah.
I think it would be a harder problem to see if the given solution is a part of one of the solutions.
Your voice is breaking, I think. What?
Hello. Yeah.
So, go ahead.
The harder part is to find if the given solution is one of the solution. So that would be the harder part in solving the problem.
I feel the harder part is first understanding the problem, like without an example. That's like 50% done. If you get the problem, it's like 50% done. Like, so the main intention of the interview is they will just give a vague statement, and you need to dig more details. Like, hey, what is this? What is this? And we need to ask him for. Sometimes they may not give examples too. We need to ask them for examples. Can you give me example? If not clear, can you give me one more example? We need to ask them actually. That's the intention.
Interactive.
Is that true for problem solving? I believe that is only true for the system design. For problem solving,
even problem solving is like that.
I mean, I've never seen that. I mean, the interviewer give you the vague statement. They try to make it clear that you understand that what exactly they want.
I mean, they give you some one example, but you may not get the statement with one example, right?
Oh yes, I mean definitely, yeah. They will not. Yeah. They will hide some corner edge cases. Those cases you will have to figure it out. Yeah. True.
But if like the statement is vague and even the interviewer doesn't know, if it's right or wrong.
Then only God will save you.
Yeah.
It happened to me once. So I think the guy who really supposed to interview me, and he was, couldn't make it at that time. So have someone take over, and that guy, happened to be not really technical. And, I asked him different clarification question. And every time I ask him, he said, yes. And, at the end, I don't know what direction it should go.
Oh, that is a problem again.
Yeah, that's a problem if interviewer is not prepared. But that's that was, I believe, that very unfortunate moment for you.
Yeah, mostly I think they'll come prepare only. Then only they'll ask. Otherwise,
true.
I mean, he has to also take care of his impression in front of the interview, right? Because let's say he gets a job, but then so both of them has to be.
I think they are also like us only, guys, you know.
Yeah,
They
exactly.
also
Yeah.
keep on reading, so we should also consider them that way. Yeah. That's
yeah.
fine. Okay. So
Yeah.
your implementation.
Yeah, it's like a dictionary. I mean, whenever you find a new ID, like first time you found 0, so corresponding to that, you add the group size. Corresponding, like let's say first group you had 3, you add that element 0 to it. Again, if you find 3, add it. Next you find something new, then make a key that and append as a list. It will form a list like this, and after that just make a result array and enumerate through the each item through the items of this. Let's say you pick the first key and go through this item and I mean pick only items up to 3, because group size is 3. That's why here we are checking it shouldn't exceed your size. The moment you find you have reached, break this into next iteration. I mean it will for next 3 4 6, and for 1 and 5. For 1 it will have 5.
Okay.
Yeah.
So you're first creating the dictionary, and then actually you are splitting the indexes based on the group size.
Group size, yeah. These are the key. Or any other than this, if somebody.
Yeah. So in this case, what is your runtime came out to be? And second question is time complexity wise, what do we consider?
Yeah.
Like you're taking. Pardon, I didn't get.
What is the runtime complexity of this solution?
And how did you stack up with other other submissions? Your
Runtime here, it's like order of n will take this for creating your map, right?
Right.
And again for iterating through.
Order of n
would be your map size plus key size.
While loop is also running inside this for, so
Right.
order of n into k it should be.
Why? It is the while loop is doing the same thing, right?
No.
No, because see, the first for loop is just looking at the keys, right?
Okay,
so he's just getting in the keys whatever the items are. He's running through that in this while loop. So it is of order of n only.
So, but for every key it's running while loop.
It's a list.
But in that case, if you have all the elements same,
it's running, but the count will
square,
be same.
right?
It's not n square, so it is list of list. And suppose if your main list is size n and sublist is maximum size is m, then your time complexity is for each item in n, you are iterating your items in m.
So this will be.
But sum of all the items in all the lists will be equal to n.
Yeah. Or is the implementation not clear?
Yeah, so it would be O of n.
Yeah, it will be of O of n. Creating a dictionary of O of n and then iterating through that dictionary will be of O of n. So O of 2n, but big O of n actually.
And the space also n.
Iterating through this list also, right? This list can be size, let's say very big size, like
yeah, but it is not going to be more than n, even if you count the 3's list and 1's list, right?
Yeah.
Yeah.
Minimum element will be n, so it's
yeah, it's going to be the same.
Okay.
But you are having a dictionary of O of n, so space will be of O of n also.
Yeah, extra space will be O of n.
Yeah, I'm sorry. Go ahead. Who is that?
Yeah, so I was telling, I think the second group is exactly n plus k, right?
N plus k or n into k? That is what I can.
N plus k, because for
because in totality
the keys doesn't depend on n. The outer loop goes until n, and the inner loop goes until outer loop goes
outer
until
loop goes number of key size.
Yeah, so that would be k times, and the inner loop.
Number of different key sizes.
Yeah.
So if that is, let's say, if there are n elements and all are different key sizes, like 1, 2, 3, all are n different key sizes are there. So that will take order of n.
So if you have a key size of different ones, So you will have to have a group size will always be 1 only, right? In that case. So you will have a single key and you will have all of those in that key.
Yeah.
Right? Because that is what the problem statement is.
So 1 will also have 1, 2 will also have only one element.
Yeah. So everyone will have 1. So group size of the whole array will be 1, 1, 1. So it is going to be one key and all of them together.
Yeah. So what is concluded from here? And
creating the result set, right? From here.
No, I'm telling the time complexity for this. Finally.
N. Order of
Yeah,
N.
of N, that is what I'm looking for.
I think we can get rid of this loop if we spawn another result the moment we exhaust the previous one.
You want to reuse it, like kind of.
Yeah, so the moment my capacity is full, for example, in this case, if I've made a vector of 0, 1, and 2, and the next, so I come on the index 3. So at this point, I do not have any empty vector of size 3, so I make another one.
I can share the single pass solution that will maybe clarify a little bit.
Please.
Okay. Let me stop it first.
Here group the people, yeah. I'm creating the result set and then the same thing map we have. This is the Java form.
Yeah.
So I'm iterating over each element. This is the group ID of at element I.
Okay.
If it doesn't exist in the map, I add it there with the array list and then add the group, the index to that group.
I mean, next time if you see the same group, you add to element to that.
Yeah. And as soon as I see that the group size is equal to the group, I add it to the result set and empty that same group so that next time I can use the same thing.
Okay.
Yeah.
So you doing the whole thing in O of N only.
Single pass O of N.
A single pass.
C is also taking extra space, that dict.
Pardon?
Yes,
dictionary you are getting.
Space will be there.
Space will be there because we have to store somewhere the result set, right?
Right.
Yeah. So whenever you see this equal to group size, you put all that element in the rest.
Not all the element till the time the size is equal to the group.
3, I mean 3 up to 3, you'll put all those things in the
and add it to that, and then we clear that same map bucket so that we can reuse it. So it will give the single pass and
So you are taking the advantage of say returning the results in any order.
Yes,
Right.
And it will be in the same order we are seeing in the array because we are just going from 0 to n-1.
Right.
Yeah,
this is also a good way of implementing.
So
one question.
One second, I'm trying to look. I have a similar implementation, but mine is little complex than what it appears here. So when there is no group ID, let's say you went to first element, there's no sub.
Should I stop sharing this so that others can share?
No, he's asking a question to you. Yeah.
Oh, okay.
I'm trying, like your code is much cleaner than what I have. Our approach is same. That's what I'm trying to say. You have this put if, and that's why it looks much cleaner. Got it. Okay. Thank you.
One more question. So if suppose here it say that everything will be valid, but if there were invalid cases as well, then what should be the case? Like if would we say that if the map still contains the elements, then return like false or
no,
return
it says that it has the valid. So we'll always have the, like if the group ID is 3, we'll have a multiple of 3 indexes.
Yeah. No, but I'm saying if that condition was not there.
Okay, then in the end, whatever is left in the map, we will add to the result set. after the for loop.
Yeah, so in that case, if say it says that the group number of element in the group should be 5 and you don't have 5 elements left with you, so you can just return invalid or throw an
So
error.
basically when we come here after the for loop, in scenario nuke in each group. So we can add at that point everything to the result set and then return. Right?
Yeah. I mean, there will be some elements left in the map.
Right.
Yeah, but that is a good catch, because there is not any mention of that in the problem statement. If there
It
is
says
a
that it has a valid, that's why.
not explicitly saying anywhere.
It is saying that.
I think it says
is guaranteed that there exists.
Oh, my bad. Sorry.
Yeah, because that came to my mind, so that was the thing.
It's crucial step, yeah.
So in this case, on line 13, you clear the entry in the map. You not delete the key, right?
Yeah,
you
I'm not
delete or
deleting.
you still keep the key there, but you clear the the container.
Yep.
Yeah, so she's trying to use the map space very efficiently too in this.
Deleting
yeah, but in case if the same group happen again, then that is efficient. If the same group not happen again, then the map will grow.
I think map will not grow because we are clearing it.
You clear that, but let's say if there's if say multiple group of 3, then that's good, right? But let's say if only one single group of 3, then after you clear that, then it kind of it's just there. We're not using.
Yeah. In anyway, we have to have some bucket, right? If it comes again.
Yeah, if
so
it
it
come
will
again.
have the size of EID.
Yeah, but that's what I'm saying. If there's only one single group of 3, then we're not going to use it again.
Yeah, I think we can delete also, right? The key can be deleted.
No, I think
no, but you never know if it comes back again. So you'll have to keep it. But anyway, you have to keep that in the map, right? Whatever the way you use it, you still have to keep the key or whatever. Either you keep the key with the results or you just keep the key. Any way implementation will have that if you use it the map way.
Yeah, I mean, even if you delete the key, the put if absent will take care of creating it again, right?
But again, you will not know, like you don't need to delete it unless if you want to use. Okay, that way, yeah. That
way.
you
don't can really delete it also.
Happen in the future.
Either clear or delete, both are fine here.
Yeah.
I think deleting
that makes sense. Yeah.
Deleting key may be more efficient. I'm not very sure on the key.
Yes, yeah. Right.
Secondly, if you have, say, in this case, right, we have 6 element of number 3, right, in the input array. What if you have 5 element, because you're not adding to the result array until line 12. So if you don't meet the group size to the group, then what happens?
No, what I'm saying, if we put it here, the delete, that will be more efficient, because in the end, if the size is very large, then map will not have all the keys unless it is needed. So the put if absent will take care of it if again we see it.
Yeah, that I got it. I'm moving on to next problem.
Okay. Sorry, let me stop sharing this.
No.
He's asking to you.
I think he is asking the same invalid entry that I asked about.
Yeah, that's we would have an invalid case. That is what the problem statement says.
Yeah. If that's the invalid case, so at the end of the loop, we can check if map is not empty.
Yeah. Then we cannot have the delete here if we want to cover the invalid case also.
So for example, in the input group sizes that you have on the left side, right? What if you remove the last 3, what happens then?
That's an invalid case.
Oh, he's saying if it is 5 instead of 6, the 3 value, if you remove the first 3, and then when you get only 2, so in that case, it won't even go inside that and add it to the result
because
value,
that
right?
becomes the invalid case. In that case, we have to put it here after the for loop. Whatever is left invalid state, we will add it to the result set if it is required, if it is the asked like.
Right, and that's I can share mine, and that's what I have done. Like
Yeah, sure.
It can be a
Let
good
me
follow-up
stop sharing
question.
this.
Yeah, yeah. Sure. So if it has 5, then 3 will be put into one group, right? And the remaining 2 will go to the.
Yeah, we'll have to do some other. Yeah.
It's not clear. I mean, that's not the requirement, so we don't know.
No, but you never know. Someone might ask as a follow-up too, right?
Yeah, so if someone asks that, then you will have to actually care about.
Yeah, so the implementation here is like that, so you can easily take care of it. But in case of someone doesn't implement it in a different way, so it won't be possible.
So
But for that case, there should be a size of group 2. Then only you will put those 2 elements in group 2. No, he's telling that if you remove 3 from here, so you'll have 5 elements of group size 3. So three elements you'll put. What about those 2? Those 2 should be put in a size of group 2, and you don't have any 2 size group.
Okay, yeah. Let's see what he has. Yeah.
Okay, yeah. Let's see.
So this is how I have done. I did not use put if absent, and that's why I have this if condition that I needed to put here, and then like this if else. I could have reduced if I put like put if absent. And then this is where I check for the group sizes. If I find the group size equals, then I add it to result set and then remove that specific key from the map.
Yeah, this covers the invalid state also basically.
Right, and then at the last I iterate
the same thing exactly,
and add it to the result if there are any lingering list.
Dangling one.
Yeah.
Oh, okay.
But what is the key for the, no? Yeah, okay. Yeah. So to the group size, you added 3 elements, and 2 just you added in another list and appended it to the result.
Yeah, so let's do that, right? Like if I take this
It
example,
won't work here, I think, because it's okay.
Let's check.
Yeah.
so I just remove say one of the 3, right? Like towards, I'll remove say the middle one.
So 0, 2, 3 should be there. Expected.
Oh, in this case, he is saying that because that is what the problem statement is. So they have taken care of it. But in your case, you have done it right, I would say. You have added that as a 3 and 5 as the last one.
Yeah.
Yeah.
They ignored it. So
they ignored it, yeah. But the follow-up might be there like that, something.
If I remove this for loop, then I think mine will.
Then it will work, yeah, in that case.
Yeah, not sure.
But why are you saying wrong answer?
Because of that orient. No. Why it is saying?
Oh, so they are not even checking the test case. So this is something to do with the lead code.
Yeah, something wrong with lead.
Yeah, with the lead code, yeah, because the output is exactly the way they have said. It can be in any order and any permutation.
Yeah, but the input is valid, so I don't really.
Yeah, but they are actually looking at the input also and then saying it's the wrong answer. But it's not the wrong answer, it's the wrong input, I would say.
And for the extra line, the second loop on line 22, sometimes it's good, sometimes it's not. I'm not, because sometimes they expected, this is what I exactly expected. If it's something wrong, then let me know, something wrong, right? You put it there, make the result come out different than.
Do we get the recording of this practice sessions?
Yeah, every day.
Yeah, we are recording too.
Okay, thank you. I'll go. Thank
you.
Yeah, but it is not uploaded the same day. That's the thing.
Yeah. Upload every weekend.
So any question, I can stop sharing.
Yeah, I think that's good.
Thank you, guys.
Thank you.
No, thanks.
Yeah, move to the next one.
Yeah.
Just one thing. For this question, we'll have 9 permutations, right?
Let me go to the question. Okay. What was the question?
No, he's talking the first before one, the guess the word, right? No, sorry, the group the people.
I have to take out that question.
Group the people, the fourth one, yeah.
What is the number?
I think it was open over there. The number, I'll tell you.
Or wait.
The second last one, the group the people.
Yeah.
1282.
I think I deleted that.
1282.
Yeah.
Yeah, it is there, but you can't see it when you're sharing it. I know that.
Yeah.
So for
Go ahead.
So the given example, there would be 9 permutations, right?
1, 2.
Okay.
Yeah.
Yeah, just confirm it.
But actually, if you look at the explanation, it doesn't talk about the rest of the permutations.
Yeah, so
Yeah,
I think we have to swap the arrays of the same size somehow.
So the order matters to some extent.
They might have missed it or something.
No, he has said only other possible solutions are, or else he could have said all the other solutions.
Possible solutions.
Yeah. Yeah, good catch. I never thought about that.
3 cross 3 is doing right. First one, any element.
It can be anything. Okay. Move to the next one.
Yeah, guess the word there is one. Okay. So the problem is interactive to lead code platform. We are given a word list of unique words, and each will be of 6 letters long. And one word in the list is chosen as secret. You may call master.guess word to guess a word. The guessed word should have type string and must be from the original list with 6 letters. The function returns an integer type representing number of exact matches, value along with the position of your guess to the secret word. And if your guess is not in the given word list, return -1. For each of the test case, 10 guesses to guess the word. And at the end of any number of calls, if you have made 10 or calls to master.guess, and at least one of the guesses was the secret, you would pass the test case. Beside the example test case below, there will be 5 additional test cases, each with 100 words in the word list. The letters of each word in those test cases was chosen independently at a random from A to Z, and such that every word in the given list is unique. Okay, so this is your secret word, and this is your word list. So when they started with into this API, the master.guess function, when they passed this, the return is -1. The reason is that because this is not in our word list. Now coming to this, all the letters along with their positions, like A is at 0 position and secret also at 0 position. Position along with the letters are at same, no change. So length of this will be written as a result. But you come to CC, BA, CC, BA, ZZ. So first C doesn't match with your A because they are at different position. But you look at second C. Second C matches with your second C. So one this, and again last 2 Z also matches along with the position. So 2 plus 1 3. So it's returning 3 in that case. And for this, if you see E doesn't match, I doesn't match, O doesn't, but ZZ matches. So 2 along with the position. And here if you see A match 1, B doesn't match, C match 2, and last 2 match 2 plus 2 4 here. So you have written 4, and we have made 5 calls to master.guess, and one of them was the secret, so we passed the test because this one. Any solutions that attempt to circumvent, okay, the judge will be result in disqualification. Yeah.
Is there any constraint? What the size of the list word?
They have given, I think, size of the list is like each word 6 letters long, 100, I think somewhere they have given size. Yeah.
So they have given more about the disqualification only. So that is what actually is more important for them. So you cannot use master.guess more than 10 times.
100 more than 10 times, yeah.
So
And
that
your
is
word
the
list
only
will
constraint.
be of 100 words, okay.
Yeah,
And this,
yeah, the word list is of 100 words, yeah. But you are not returning any output here, right?
And length will be, no, since it matches no here, so yeah, he is not returning any output. It will automatically, I think, take lead code. Once it finds that you have matched it internally, it might.
So yeah, whenever you get this right, when you are able to find a secret word, so you just return it from that.
How you did, yeah.
Yeah, so you don't
How
use
do we pass the secret word? Because I don't understand that how we have to create the signature or.
No, we have to guess it actually from the word list, which might be a secret word by using that master guess.
Every time you have to return the number, and when this number matches with the lead codes, whatever they have, true number for that, then I think that will be accepted as a solution.
So what you need to do is traverse the word list one by one. Okay.
Yeah.
The best way would be if they would have not had that constraint. And each time when we have a word from the word list, pass it to the master guess. And if it is equal to the number 6, because the letter size is 6, if it is 6, it means all of the letters match, and that is the master key.
You have to take care of position also, that at that position the same letter should be present.
Yeah, so when you do that, the master guess does it, right? So whenever you push that word in the master guess as a parameter,
we don't need to implement that.
Yeah, we don't need to implement it. Yeah.
Yeah.
So if it returns 6 means it is matched. And if it doesn't match, keep on continuing. So if it's an iterative way, and if we had a no constant, then that would be a way to implement.
I have a doubt here, like still now.
Do we sort the word list and then?
No, orientation matters. No, how you can't sort it.
No, you can sort it. I think that should not be a problem. Sorting
no,
a word
you
list
cannot
is not a problem.
sort it because it based on the position, right? That's how it match.
No, position of in a word list, a word in a word list, in that the position of the letters is important.
That is he's telling that entire word can. So how will she sort? Lexicographically only.
Sort the word list, not the word.
So yeah, she can sort the word list, not the words, letters inside
characters.
A string. Yeah.
Okay.
Because if we sort it, then we can do the binary search and then call the guess word, right?
Exactly.
Binary search.
Binary search won't work. I think I was also thinking about that, but because whenever you pass through that master guess, it's not going to give you the exact number, or maybe an incrementing way or a decrementing way, right? So I'm not sure how. Maybe there is some way to do
that
it.
makes sense. Yeah.
No, help me understand the question. Do we need to match all the words? Then we say it's matching, like we pass the test, or we need to get the maximum, or we need to all the words in a single.
All the words along with their exact position.
Okay.
Like A is here at the same position. C at the same position, and at last your length, the entire length.
So my question is, can it be like ACC in one word and KZZ in another word, something like that, or it should be in the same word?
It should
no, they all have the same length. And each word is 6 characters.
Yeah, in the same word. So you have to actually find that secret word, whatever is given there.
We have to check for that word. Like, I don't know why they given like written 6, written 3, written 2. It's like
this is because only those many are able to match. When you look at this CC,
I mean I understand that, but the ultimate result is like we need to find the matching word, right?
Oh yeah.
Yeah, you need to find, but we need to use their API.
Master.guess.
But do the binary search, the number returns that how many characters it matches. On that basis, we can move left or right, right? Because if
you can.
I'll try there. I don't know.
But you do the word the you sort by the word list, right? So the order of the character in each word is not guaranteed to
That's correct. Yeah.
So you cannot do binary search there.
Because the positions are different. So you will get different results every time. Yeah.
But let's say, suppose, we do the guess and let's say return 2. Then how do we know what the 2 character are matching?
Yep. So therefore, actually, you go through the whole list, find out whichever are the 2s which are matching with the candidate which you just took for the guess, and then form another list and just use that list. So you're actually reducing the problem statement, right?
Yeah.
So you're trying to narrow down.
Again, please.
So what is saying is, like, if you use any candidate, like if you use something like the CCBAZZ and it returns 3. So when you returns 3, what you can do is go through the word list, and now you know that you have CCBAZZ which has returned 3. So you compare that with each and every word list and find out if there are any numbers which it matches with 3. And then you form a separate list for that, and then you pass through the whole thing again. And then you start using that list instead of using the whole list. So you are condensing, then narrowing down the problem. So at least one of the word will have that length, that is for sure. We just have to find the next others. Right, I think this implementation also similar way, right? Because there are many implementations for that, because the solution what they have shown is a very hard way of implementing it. I never followed that, the min-max one. That's very difficult to understand.
It's a standard algorithm, something min-max, right? In A-star algorithm. Something,
yeah, but here the way he is implemented, it's very difficult.
Wait, the standard, can you tell at the high level how does min-max algorithm work?
I have heard the name like many times, not like, but I've heard many places this algorithm. Anyways, let's see what is.
It is something to do with AI, right? So this min-max.
AI, A-star, AI, exactly.
I think Gaurav Sen has a
video for that
too, and I try to understand it, but it's not so easy to. Yeah. But it would be a good thing to actually look for that as an exercise. But for our problem statement, we don't have to go in that details. It is very easy to implement, right?
Yeah, let's see the easy version and then of the harder one.
Yeah, I think
because I couldn't think of how to do it.
Yeah. So I also went through the discuss sessions and I found out, then only I could understand it, because the solution was very difficult for me to understand.
Difficult, yeah. I took it from there only, but let's see. So here what I'm doing is, this is what will, when you're go through each of the word and see if your character matches, you sum them. You increment it by 1 every time. And this is your possible, this list I've taken, a set I've taken for this. Now what I'll say, in order to make it deterministic, because I think every time this is a guess, every time you pass a word, it may give you a different result, right? Random.seed what actually does, if you are into machine learning, you'll see that when you split a data into train and test, so you might have first time 60%, 40%. But if you do, so next time again, if you execute, you'll have again 60%, whatever data you had, first time you executed, you had 1, 2, 3, 4, one set, another was 5 and 6. But if you don't use random set, the next time if you take, it will take 4 numbers first, but those 4 numbers might not be the same which you have already taken. So in order to make your result reproducible, we use this random seed. You fix any number. It's not, I mean, any arbitrary constant number you fix. For namesake, it's 42 here. You can put any number. And
so it is randomizing the choice, right? That is what
exactly,
you're trying to say. Okay.
It is making deterministic.
Okay.
I mean, each time you execute the code, you'll have the same result.
Okay.
Yeah.
Can you copy paste this in the chat so that I can go over, because
yeah, sure.
You can even share in that.
Go ahead and paste it. I'll do it and then.
Okay.
Okay, so what the first line does, can you give an example?
The first line is slightly.
Okay, well, I'll do it. I'll do it after this. I'll put it in the Slack. Yeah.
Okay, thank you.
Yeah. Okay, yeah, sure. Thanks.
So the way I did actually also okay, you go ahead with yours.
Yeah. Yeah. So I mean, something
Leon was asking about the first line.
First line, like I'm comparing character wise. Okay. I mean, taken two words. The S1 as the secret word and S2 as any other word in your dictionary. You match the characters. C1 matches with C2. You make it one again next time. Append it like increasing how many characters are matching with yours along with the position, because JIP will take care of that also. Position, if the at that position the character matches with the other word, then that will be considered as one.
Okay, so after line number 1, what the dictionary look like?
After line number 1?
Yeah.
1 you don't have.
No, line number 10, I mean, yeah.
Oh, your dictionary, I think here it will give you like, here I don't think it should give you any output because it's not displaying anything.
So count the number of characters that are the same.
Yeah. Along with the position, like at that position, if it is present.
So is it like you're just defining that dictionary here?
It's not a dictionary, but it's an lambda is just for using anonymous function for declaring any function. You took this word and you match, if this is your secret word and this is your every word, you'll match it with, if in character and position everything it matches, then it will return you.
So you're using that in that for loop, okay, while loop. Got it.
Yeah. And these are the possibilities, all the word list I took in this for. So your choice can vary. So every time you're fixing your choice and corresponding to that choice, try to obtain the number, like whatever score you're getting. And next time, if you visit the same score, so the reason behind using it that you shouldn't have the duplicate. Like you got two similar search words like ACCKZZ is there and again ACCKKZZ is there, to avoid such scenarios.
Okay, yeah, you're having a set for that, right? Okay.
Set for that, yeah. And then just what this, I think here you'll get what I'm doing here, for every word in your word list, a pair of this will be passed into this function and it will check whether the score is equal to 6 or not, and W not in seen. If it is not visited, if that word has not been visited till now, for every new word, pass it into this dict function and it will return you the score. If that matches with your score 6, then that is one of your that is one possibilities. And if otherwise, if your length of possibility is 0, you just return.
Yeah, because if length of possible is 0, it means you have found it, right?
Found it, huh?
Okay.
What if, like, the master guess, it return the score of 0? That means whatever, belong to it would not be the right word, right?
So it means that in that case, you are going to take all the word list again, right? So,
yeah,
so you're not narrowing it down. So the main purpose of master guess, you need to use it so efficiently that you need to narrow down your input statement.
Yeah. Huh.
Right. So if you get all it's okay. If you get 0, still fine. You're again going to use the same thing again. You're going to use a whole word list. But next time when you do random again, that is the reason we have to do random. So we don't go and hit the same one again. So you find a different solution. Okay. And therefore the choice is different.
When we get back is 0, right? We know all of that character are invalid, right? So we look for the list we look in the list of word, and we see, you know, at that position, if that match with the character, then we know that word is not automatically should not be the right one. So we can eliminate the whole, you know, the whole group. Now, you know, we have left over which, you know,
okay,
could be smaller.
So in that case, I would think, you know, the way the word list has been designed, at least one letter would match.
Solution would be there. Yeah,
I think maybe that is the way they would actually give us the test case, use case.
No, but there's only 6 character, right? But we have 26 character possible. Then, you know, some word is not gonna match. You know, there's a possibility that,
yeah,
you know,
there is a possibility, but they would actually create a word list like that, because then it won't make any sense, right? So if they return a 0, it doesn't matches, then if you are actually reducing the word list to 0, then the input will be none.
No, yeah, but they could, but that could happen. You know, I think it could happen. Let's say half of the, you know, half of the word in the word list are invalid. Then, you know, we can remove half of it. Then we look at another half. But let's look at the statement. You say, you know, it gonna return, guaranteed to return, you know.
Yeah, it's not
1.
written there like that.
No, it's not written. They can be none of the word.
Yeah, none of the word also.
Yeah, so it can be 0.
Yeah, so that is the reason the first example where he says, if you pass AAA, right, the master guess, which is not in the word list, then you should return -1. But in your case, what you are saying, if it returns 0, then you can maybe return -1 there.
No, but that because we see that they pass in AAA because AAA is not in the word list, right? That's still possibility that there's a word in the word list, but it you know, the score would return 0. It doesn't match it, you know, any of the secret letter.
Mm-hmm. Yeah, maybe we can actually create a word list like that and pass and see. Yeah, that also. But we don't know, because the master guess implementation is different, right? Your input.
Yeah.
You don't pass the. Oh yeah, you pass the master also, right?
Yeah.
Yeah, you can try and do that,
yeah,
but yeah, but that will be slightly difficult to.
And this is a choice, like, yeah, go ahead.
That's the same. I think that's the same way that when we guess, right? When we guess, we say, okay, now get the score back up 3, right? And like you say, Santos, we're gonna look through that and find all the words that have the, you know, match that 3 character. Now we narrow it down to the smaller subset. You know, that is we narrow it down. But the other way is when the score is 0, we exclude it, and exclude it is also the same as, you know, when we narrow it down.
Yeah. So excluded, like if you see when it is returning the score is 0, it means none of the letters are matching, right?
Right.
With the master secret.
Yeah.
So if we run through the word list, there will be at least some words, okay, which will match with the master, right? So if we exclude this word, the word which is 0, so only those words with these letters will be excluded, not the master's list which has a master in it.
Right. Yeah.
So you will still get some valid statement, I would say.
Yeah. So for example, you know, if we get the score go back is 0, right? And let's say the first letter of that word is A, right? And now we go into all the word in the list where, you know, it begins with letter A. Then we can eliminate those one because that guarantee those one are not valid.
Right. Yeah, makes sense. Yeah, we can eliminate that, but we'll still get something which is, because that won't be a part of master. But if it is a part of master, then you won't get 0 there.
All right.
Yeah, you're right. Yeah, that makes sense.
Yeah, any queries in this? I think.
Yeah, this is a very efficient way of implementing using a randomized way.
Yeah.
So I used a very clumsy way first because I had to understand the whole thing.
Yeah.
So I used a queue. Okay, first I sorted the word list because
Okay.
I think someone was talking about that, right? Sorting it. So I
Shweta,
sorted the
yeah.
word list. Yeah, and then I was also thinking of going the binary search way, but it didn't work. So sorting it, then putting it in a queue like the BFS way, and every time send a single candidate to a master guest, and whatever you find, okay, means whatever it returns, out of that you just subtract 6 minus it. So those are actually not there, and then you run
Why
through the word list.
Q are you are using? Like what?
Yeah, I was trying to use the BFS way.
Okay.
And then create a word list of all that. I told you, right, a very clumsy way of doing it, but I thought I need to
Yeah.
understand the whole thing. So then I
Yeah.
compared with each and every candidate and found the difference. If the difference is not equal to found, then I created another list saying seen, something like that. Okay.
Already, huh?
Yeah. And then whichever are not in the visited array, I just push them in the queue. So those are valid ones, right? So instead of
Words.
taking the correct ones, I went the way actually I thought I would pick up the ones which are not there. Okay. And then put
Yeah.
in the queue. Yeah. So that was my implementation earlier.
I think in your case, Santos, I think if you go the same implementation, but we go to the depth first search, probably it would be better, right? Because let's say you go the first one and it, I don't know, like if you go the first one and it match 4 character, right? And then you go depth first search, deep down, then you have more chance to match.
Right.
Yeah. Then if we go like, breadth first search.
So how did you get this intuition of BFS? Like, I mean.
Well, no intuition actually. I just went through the discussion sessions. Okay, I was
Yeah.
trying to first understand how the implementation would be because when I looked at the solution way AY is, the guy who actually wrote it, it was very difficult for me to understand. So I went to discussions and I just found these two implementations. So I was trying to understand how they have written it. So I like the way because BF is very easy to understand, DF is very easy to understand. So I started looking in that. And then when I saw that, I said, okay, this at least works. Okay. Then I started looking in the randomized way. And then I found the randomized way is the most efficient way of doing it.
Yeah. Yeah, because BFS, I mean, can't even come in dream like thinking this one as BFS.
Well, yeah, DFS and BFS should be okay, right? Like the way Leon was explaining now. So if you find some word match, right, you go and pursue that list, right? So you use the DFS way, right? So you now have a word letters which you have a match to, okay? Then go and pick up only those letters in the word list which have match to. So you have that problem statement narrowed down. And then again do a DFS for only that list, right? So in that again, if you put that, you will surely going to get more than that, not lesser, right? The score will be more.
More, yeah.
Yeah.
That
So when the
greater
score
than
is
2,
more,
it will be,
right? So again, you pick up from that only customized list what you got, only those one which have that score. So you are narrowing it down, and your possibility of getting the answer is more quicker. Yeah, I like the way what Leon said. Instead of even doing the randomized way, we could just go the DFS way. It would be much easier.
Like DFS where it's coming, like, I mean, you are matching for, let's say, 2 word matched. Now you'll get all those letters which have greater than 2 words matching with the secret, right? You'll narrow down the list. Remaining will be kicked out.
Yeah, just remove the remaining one. Just only take that. So it is more than a DFS. It is more like a recursive way. So sort of you can like a memoized version, a DP solution, something like that.
Yeah.
But I think that should be doable way.
Yeah, then if the score is 0, then you do the other way, right? You get you exclude it.
Exclude it. Yeah. But still you do the same way, right? You just keep on recursing it and getting all the least.
Makes sense, yeah.
Yep.
But because when DFS comes, height and all comes into picture, it's okay.
But with the randomized, how do we know, when we get better answer? I mean, better result.
But I think randomized way is also doing the almost a similar way, right? But only thing he's randomizing it, right? So now also, if you look at it, he's not doing the iterative way though, but actually he's going here, and when he gets puts that candidate of choice in a master guess, so he get a score. So based on that score, actually he's narrowing it down. To some extent, it is similar, but it's not the way DFS is implemented. Yeah. But at least we now know some way to handle such problem, right?
It's totally out of box, like
Absolutely, it's very difficult to get to the solution.
Yeah, but the limit is only 10, right? Even if we do DFS, it's still possibility that we need more than 10.
No, if you do it the DFS way, why I'm saying it will be within 10, because you are narrowing down in such a way that you are doing like a binary, going down a binary tree. So you cannot go depths more than 10 to get to 100 solution, because the word list maximum size is 100, right? So if I don't think if you look at the way you go through a binary tree also, you don't need more than 10 depths to get all the nodes of 100, right? So 2 raised to 10 will be 102 for combinations. So you should be easily getting that before it.
If we look at the example, so last 2 letters, every word has last 2 letters as ZZZ. So if we go by DFS way, it means that all the numbers, all the letters, words will be in the list.
Yeah. And also we have 6 only, right? Yeah.
Yeah, but we can have more, right? And then we can exceed the 10 limit.
No, 10 is the at max. Yeah, I think if you have made 10 or less calls,
it's only 10.
Yeah. So can't we have a word in a word list in which last 2 letters won't be ZZ?
We can, but we can also have a worst case where every word has that last 2. Here, this is a worst case, right? Every word has the last 2 letters as ZZ.
ZZ, yeah.
So even if you have every letter as a word last case ZZ, so it comes down to what Leon was saying. Either you have a score 0 or you have a score 2. So you are taking all the word list, right? So, but then when you randomize it and take at least one choice, so there will be another choice, because now you have exhausted with that 2 score. So it will have to give some other score. So the score will always increase, not go down, right? So therefore you are always going in the upper direction. So you're always narrowing down.
Yeah, I think the randomizing is the key, because if we go serially, then possible that all the words have only 2 letters in common, not more than that. So
yeah, but it's a good thing to try, see if the DFS way works. Yeah.
Yeah, but even with the randomized, we may end up select the same word again, right? So
no, you can't. That's why.
But that is only for once, right? So if you choose,
that's what dictionary you are using, no?
Oh, okay, you've seen it. Okay.
Here you will catch that word. That if you have already seen that word in dictionary, next time you can't pick it up.
Yeah, either you do it that way or you do it this way, reduce the possibilities.
Leon, yeah.
Yep.
But in the worst case, let's say when even we have the our word have last 2 letters ZZ, right? And then we select one and we get the score of 2, and then we randomize, we select another one, we get score of 2 too. right? That's possible.
Yeah,
Right?
that is possible. But if you see the level of tens, because every time you are actually, okay, but it won't happen like all the 10 of them will have only twos, right?
We have 100 of the word.
100 we have 100 little words you can have.
But if you have the last two, then the word size is also of only 6, right? So you have only 4 remaining. So how many things you can change in a 4?
The
How many times you can
permutation
change?
of 4, yeah.
Yeah, but you have 26. Yeah, that might be possible.
No, I think randomizing is the key. Like we just randomly choose a word and then like just guess.
If it could match your score.
Yeah, yeah.
But random is it's still, you know, if it still return the same score, then, you know, every time you randomize, you only select only one. I mean, you only remove one word
from the list.
Yeah, effectively, right.
Yeah, but it is working on here. Surprising. Yeah, that is some key which we actually are not aware of. Yeah, that is a good point, Leon. Yeah, but I will try the DFSP and see if it works, and then I'll update on the Slack.
Should I think? Yeah.
Okay.
Yeah, sure. I'll do that. So at least we are clear whether at least we have to use a randomized way here. That should be one thing.
So such questions can come in interview, right? And they have written it's an interactive problem.
People can ask anything, you know, so I think it is always good to prepare the way it is. It's not that bad also when we actually did a good postmortem. I had a good discussion on it.
Yeah.
So we at least have some tools, you know, to break it down further.
Narrow it down to simple.
Yep.
Yeah. Okay.
Okay.
Okay. We can wrap it up.
Okay.
Yeah, wrap it up.
Okay. Thanks, Andrew. Thanks, Leon.
Yeah. Thank you, Shang. Thank you,
Thank you,
Leon.
guys.
Thank you. Yeah. Thank you.
Right.
So I'll paste it in the, I think.
Yeah, you'll have to paste that, okay?
Yeah. Yeah.
Bye.
Bye.